Well, no, I didn't.
I want to know what I got.
So on this, if you're just looking at these names, you got to be able to do this. With me, Riley?
Yeah.
Name me a segment in this triangle.
QR.
QR. Make sure you're using your symbol. Segment QR has to be congruent to what in the other triangle?
FG.
FG.
Okay.
Do we really need to draw the picture?
No.
Name me another segment in this triangle.
RP.
QP, I heard. I'll do that one first. Is congruent to, what's that match up to in this one? FK or KF, either way, it doesn't matter. And what's the third pair?
RP and GK.
Segment RP has to be congruent to segment GK. Now on the angles, I said you could use a symbol and just one letter. Pick me an angle in this first triangle. Angle Q. Angle Q has to be congruent to what angle in the second triangle? Angle F. Now, all the time, can you always name them with just one letter?
No.
No. These, it looks like you can because they don't share any letters, so you're probably fine. Name me another pair of angles.
R and G.
Angle R has to be congruent to angle G. And what's the last pair?
P.
Angle P has to be congruent to angle K. You said number 7? Is that what somebody said on page 330?
Oh, yeah.
Problem 7. Problem 7, they give you a triangle, it looks like this. I don't have a graph on here, so we're just going to have to, you're going to have your books out and help me out here. That's supposed to be a right angle there. Mine doesn't look like it.
You just need a smart board.
Somebody help me out looking at your book. What's the coordinates for point F? 0 what?
4. No, that's a 3.
Is it 3?
Yeah.
How about E?
0. 9.
D?
Oh, okay.
4. 4, 6.
No, it's 3. 3.
It's 3?
Is it?
Yeah, 3, 5.
Yeah, 3. It's 3, 6, Calvin.
6.
3, 6?
Yes.
Is that what we're going with?
Yes.
Right. Now, what they wanted you to tell each angle and tell each side. The sides, we're probably going to have to use the distance formula on, except for this one. How can we find this side?
Count.
Count. So somebody do that for us.
6.
So one of our answers is just 6. This side over here is just 6. Which side do you want to find next? DF?
They don't need the side lengths.
They don't want the side lengths this time?
No.
Well,
But we still should find them.
I'm telling you that we're going to have to find them, otherwise we won't know it.
I know.
So,
I saw some.
with DF, remember this is an X, that's a Y, that's an X. You got to remember your distance formula. That's a Y. What's the X's this time? For DF. Oh, we said DF, I'm sorry.
3 and 0.
0 and 3, 3 and 0. I'm going to put 3, 0, just to make the subtraction. Have your calculators out. You should already have them out because I just walked around and graded them, right? Done homework.
You did?
If you did, yep. If you didn't have it out, it went down to 0.
Dang it! Ah.
Not asking anybody anymore to have them out. 3, 0. What's our Y's?
6 and
6 and 3. So 6 minus 3. What is 3 minus 0? 3. 3 squared.
9.
So we got 9 there plus 6 minus 3. 3 squared. What's 9 plus 9?
18.
Square root of 18. Somebody help me out. Tell me about approximately what the square root of 18 is.
4.2.
4.2.
Yeah.
That side, I keep writing it on the wrong one. That side is 4.2. Now to find DE. do the same thing. What's our X's on D and E?
0 and 3.
0 and 3. I'm going to turn them around again just to make it a little easier. What's our Y's?
9
and 6.
9 and 6. What is 3 minus 0?
3.
3 squared.
9
9 minus 6.
3
3 squared.
so it's the same.
18. Square root of 18 is 4.2. What's that tell us about this triangle?
The 2 corners are the same.
It's an isosceles triangle. If those two sides are the same, then what has to be true about those two angles? They got to be the same. If this one's 90, how can we find those other two then?
Subtract 90 from 180 and divide by 2.
So they didn't ask us to find the sides,
No.
so we didn't need that answer. So subtract 180 minus 90, what's that give us?
9.
Divided by 2,
45.
45. So the other two angles are 45 degrees. Is that all they ask us for? Those two answers. Got to be able to do the distance formula and stuff still. Don't forget about them. Other questions on 330?
We did number 10.
Number
9.
9. Number 9 says find the value of x.
Number 9.
Oh, no, I'm sorry. I was reading 10. Number 9 says find the measure of angle B and the length of segment AC. So they give us this triangle. This is A, that's B, that's C. They tell us this side's 3, this side's 3. This is 60 degrees. I think that's all they tell us, right? What do we know about if these two sides are both 3? It's isosceles. So if that's the case, then what has to be true about those angles?
2 angles are 60.
So if that's 60, this angle has to be 60.
Yeah.
Well, if this angle's 60, this angle's 60, how much is left over for this one?
60.
That's one of our answers, right?
And it's equilateral.
Now, if that's the case, then not only is it isosceles, but it's equilateral. So what do we know about this side over here?
It's 3.
It's got to be 3, and that's our other answer. So
Okay.
measure of angle B is 60 degrees, and the length of segment AC is 3. Next question.
11.
It's the same problem.
Yeah, never mind.
Is it same?
I mean, pretty much. They just flipped it.
So if these two are congruent, what do we know about the angles across from them? They gotta be congruent. If this one's 60, then that means there's 120 left over for those two. So how much is each one of those? 60, 60. And if that's the case, how long is this side?
7.
7. What'd they ask us for?
Y.
Measure of angle Y and segment WY. I think that was segment WY, wasn't it? And angle Y was
That top right one.
this one. Other questions?
Do we have to do 15? Yes, we gotta do 15. Okay, 15.
Problem 15. They give us this yield sign, and they tell us that, I guess that those two sides are congruent, right? This angle is 60 degrees. This is 3x plus 9, is that correct?
Yeah.
And what's this other one over here? This other side?
4x plus 2.
4x plus 2. And what's this up here, 4y, is that what it says?
Yeah.
Yeah.
That corner? If these two sides are congruent, what do you know about the angles across from those two sides?
They're equal.
They're equal, so if this is 60, what's this one up here have to be?
60.
60. So 4y has to equal 60, how do we solve that?
Divide by 4.
Somebody help me out.
Y equals 15.
Is that what they asked us for, was find x and y? Yes, no, maybe? Yeah, so this is the answer to B, right? Now, if that's 60 and this is 60, what's this angle over here?
60.
So not only is this an isosceles triangle, but what do we know about it? All the sides are the same. So that side should have 2 marks, so what do we know about these two?
They're the same.
So 4x plus 2 should equal what?
3x plus 9.
3x plus 9. Subtract 3x on both sides. What's that leave us with?
X plus 2 equals
Just cancel. Now what? What's that leave us with?
X equals 7.
And that was the answer to A, I think, wasn't it? Other questions? Is that it?
I need help with.
If you didn't grab the notes up there, grab them. This was number 16, just to show you this. Number 16 on there, we had to show that all 6 parts of one triangle were congruent to all 6 parts of the other triangle. To prove the 2 triangles are congruent, this is what we're going to be doing for the rest of the chapter. And this problem looks something like this. Give me a second, it'll just take a minute for all of my movement to come up here that I wrote down here. So on, so on, so on. Notice I even put some things in the same step and probably shouldn't do that just because this one was so long that I didn't want to write it all out. And you'll notice here in a second, now I run out of space. And I even had to come over here to the other side and do all of this. Start all over again for step 9, step 10, step 11, and then I'm finally finished. We really don't want to have to do all that if we don't want, or if we don't need to, all right? And what we're going to learn the rest of this chapter is how to shorten that up. There's ways that we can prove that those 2 triangles are congruent without going through and proving all 6 parts in one triangle congruent to all 6 parts in another triangle. All right? So that's what we're going to be doing, is shortening them up. We are going to be doing a lot of 2-column proofs. These 2-column proofs probably going to be a little easier than the other 2-column proofs, just because there's going to be a pattern sort of that you're going to follow every time, all right? And the title, if you look at the title of your notes, it tells you what the patterns are. So proving triangles congruent. Fill in what you need to fill in on this. I think there's some on this first part you actually have to fill in. And we're going to write some other stuff with it. Proving triangles congruent. We're going to be doing the 2-column proofs again. Again, they're going to say in the book, make sure you listen to this, flow or paragraph. What I tell you earlier this year,
flow.
if it says to do a flow or paragraph proof.
Do a 2-column.
Always 2-column. We're only doing the 2-column. We're not doing the flow or the paragraph proofs. All right. So if it says that, don't come in here next time and say, "Well, it said a flow proof. I didn't know how to do it." Because what I just tell you, it's 2-column. All right. That's all you're doing. Does anybody remember what's this SSS stand for?
Side,
Side. Now, what that's telling us and how this is going to shorten up and make things easier to prove that these triangles are congruent is if I'm given this triangle and this triangle, and I'm trying to prove that those 2 triangles are congruent, all I need to do, instead of proving all 6 parts, I only need to prove those 3 parts. So this pair of sides congruent, this pair of sides congruent, this pair of sides congruent. So instead of having 6 steps for sure, I'm cutting it in half. Alright? So I prove these 2 pairs of sides are congruent, I prove these 2 pairs of sides are congruent, I prove these 2 pairs of sides are congruent, then I can say that the triangles are congruent to each other. Anybody remember what this one stands for? Side angle side. So now I prove a pair of sides, a pair of angles, and another pair of sides, and then I can say the 2 triangles are congruent. Lots of 2-column proofs for the rest of this chapter, and that's what most of it's going to be. And when we get to the test this time, if you just skip over the 2-column proofs like several people did the first time we did them.
You can get like half of it.
Right. Yeah, and that's what you're going to be able to get more than half. Because of these patterns, it's going to make it a whole lot easier if you just try. If you don't try anything, then you know you get a 0. Which I said all of this when we did the 2-column proofs before, and guess how far that got me?
Well, how you can sit here for
Well, with a lot of people, it got me nowhere. Fill in what you need to fill in on this one. So or SSS, you just told me it stands for side, side, side. So a pair of sides, another pair of sides, then a third pair of sides. Then we can say that the triangles are congruent. Once you've proven that or shown all the information to show that the 2 triangles are congruent by using side, 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 you have to match them up. Somebody name this first triangle for me. It makes absolutely no difference. Just because it's Kellen, that doesn't mean that he's right. It makes no difference how you name the first triangle. What matters is how you match up the second triangle with the first triangle. So what's another way we could have named that first triangle? WGP. Alright? So should anybody miss this one? No. Now, could you miss this blank? Yeah. This one here could be any way. You can name the first one however you want. Second one, you just have to make sure you match it up. Now I look over here at the P.
So is it MHD?
P is between which 2 markings?
And our
1 and 2. So the one over here that's got to go with that is the one is the angle that's between the 1 and 2. Which one is that?
M.
Angle M. D. W is between the 2 and the 3. So what's it match up to? D. And then the last one should be pretty easy. The G has to match up to what?
H. H.
Again, could you have named them different ways? Yeah. Side, angle, side. Fill in what you need to fill in on that. Now, as we go through and do these in this chapter, side, side, side is not a real big deal because you can't get the sides out of order. Right? If you got 3 pairs of sides, that's all the triangle or the 2 triangles have. They don't have 5 sides or 6 sides or anything else. So no way to get them out of order. Side angle side, little tougher, because you can't just pick any pairs of sides and any pairs of angles. They have to go in the correct order. So we picked this pair of sides. That's our first pair. So we know one pair of sides are congruent. Then we got the one that's marked with 2 here. That's another pair of sides. The only way that this will fit side angle side is if the angle is between those 2 sides in each triangle. It's got to be what's called the included angle. It's got to be included between the 2 sides that you're dealing with. Does that make sense? Cameron, that make any sense? You gotta make sure you understand that. It's gotta be the angle in between. So if I did this, if I gave you another triangle here, and we're looking at this, and we'll call this one ABC, and this one NTH. I told you this side was congruent to that side, this side was congruent to that side. Which angle does it have to be in this top triangle? B. Does everybody see that? It has to be that angle because it's between the 2 sides. Which angle does it have to be in the bottom triangle? T. It's got to be those 2. It can't be anything else. All right? And as we go through and do this, I'm going to show you this, and Michael will have a good laugh. If I did this, if I had 2 other triangles, we'll call this one ABC again. We'll call this one NTH again. If I did this, those pair of sides are congruent, those pair of sides are congruent, and we looked at that pair of angles there. Now it would no longer be side, angle, side. Now it would be what? Side, side, angle. Does everybody see that one?
Kind of.
Never, ever, ever. Now, apparently you guys don't get the joke. So,
What's the joke?
Yeah, what was the joke? I didn't- No, what was the joke? I didn't get it.
Oh.
No, guys, play now.
Luke thinks he gets it.
I think I get it.
That one never, ever, ever works. And you'll probably figure it out as the chapter goes along. Why it never works, because we could turn these around. If I turn side angle side around, what's it going to say? Side angle side still. If I turn,
Yeah, I get it.
if I turn side 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 around, what's it going to say? So it works either direction, all right? That one never, ever, ever works. Never. Does everybody understand that?
Yes.
So if you come up with something that looks, and your reason's going to be that, it's wrong. Let's do our triangles here. Make sure you're using the triangle symbol. Somebody name this first triangle for me. A-N-T. What's the A in this triangle match up to in the other one?
Oh.
Oh, everybody agree with that? Is that right? What's the N match up to in this triangle?
L.
L. And what's the T match up to in the other triangle?
R.
Is that the only way you could have named them? No, there's like 9 different ways you could have named them.
You say.
Actually, 6 different ways, I think. 6 different ways you could have matched them up. That's one of them. Make sure you're using your symbol. Make sure you're matching them up correctly.
Is it 'cause if you flip SSA?
Hey, we need to go through it. If you don't get it, you don't get it.
He's still working.
We're not gonna go through it.
There was an awkward silence.
I don't think it's very funny.
I hate awkward silence.
Next one, a stable figure. To make a figure a stable figure. And this doesn't really have anything to do with the other stuff, it's just thrown in here. To make something a stable figure, You draw in the diagonals so that the only shapes that you have in your picture are all triangles. So if you're building something, if you're an architect or you're just building anything, to make it stable, you want triangles. A triangle is considered a rigid figure. And it's considered a rigid figure because if I build a triangle and I stand on it, it's not going to collapse. If I build a rectangle and I stand on it, what's real likely to happen?
The top will bow in.
It's going to collapse. It's going to like fold and collapse. All right? If I built this pentagon and stood up here on the tip, what's very likely to happen? It's going to collapse. It's going to smash down. All right? So to make these figures stable, what we have to do is pick a corner, pick a vertex, and you're going to draw this on your paper there, and we're going to draw in diagonals so that it becomes a stable figure. And what you need to do is just connect it to every other corner that it's not already connected to. So you're going to go like this, draw a segment over there. What shape did I form up top here? Triangle. Now if I stood on top of this, what would happen? And it should support me now. All right? Draw another one down to here.
I have three triangles.
Now we have 3 triangles. Every shape in here is a triangle now. That makes it a stable figure.
So you want
All right.
other angles?
Nope. Oh, no. No, that's, as long as every one of these shapes is a triangle, you should be fine. Now, if you're building a bridge or something, and you want to make sure that it's really stable so it doesn't collapse after cars drive over it over and over and over again, then what might you do? Then you could draw in more of them and make it real stable. And if you look underneath bridges and stuff, a lot of times that's what they'll have. They'll have those X's underneath there where they're making everything into triangles. What if I pick this corner? How many diagonals do I have to draw in this one?
2.
One diagonal.
Just one. That makes it stable. Right?
You know, slide off.
If we're building a wall, we got our studs going down through the wall. Do they do this? No. They put 1 because then it makes it stable. All right? Now, if you want it to be even more stable, could you do that for each one? Yeah. All right, so if we're just building a wall, we don't have any wood walls in here, but if I was building this wall out of wood, and there's pressure on it, but it's not a whole lot of pressure coming straight down. It's not like we're driving a tractor over top of it or something. Then one of them's probably enough. But if we have a bridge or something, an overpass, then we probably want to make sure it's really sturdy, and we might want to do this to it. And that's what you see on overpasses. So if you had this overpass and it was built that way, you would see them with the struts going both ways. Pick a corner here. Which corner you want to pick? Top right? Let's do this. A, B, C, D, E, F. So we picked F. Tell me, what do I need to connect F to?
B.
FB, FC,
We don't have that one.
FD.
We don't have it. Where? Right there.
That one. Sorry, you want
Yeah, it's just that yours looks different, doesn't it?
Ours is different.
Yeah, it's just stretched out because when I copied it from the PowerPoint to the paper.
Can't do our notes.
So that's the same thing.
This never happened before, has it, Branson? Yes.
Can't do our notes.
Uh,
Okay.
No, you should pick one corner that you're drawing them from. So you got an extra one in there. I ended up with only what shapes in this? Triangles. that makes it a stable figure. So if you're doing some kind of architecture work and you can end up with just triangles, that is going to make it stable. Now again, could I make it more stable by putting in other supports? Yeah. You could even make it more stable, like our wall right here, by making the whole thing solid. Well, sometimes you can't do that because it either weighs too much or whatever. So if you go down to the overpass that goes over 70 down here, and you look underneath, if they would have took the overpass and made what they have to support it here solid steel, would that have been stronger than just putting in the supports? Yeah. The bad thing with that is it probably weighed so much that what would it have done over time? It probably fell because of gravity. So you got to have that. There's got to be a common ground there. Again, no flow proofs, no paragraph proofs. So if it says flow proof or paragraph proof, you're just going to do a 2-column proof. Find this on your paper. We're going to do a couple of these examples together. If you're not filling it in, I'm not even going to complain at you because you're just ignorant. You're not filling it in. Got these examples right here in your notes. You can use them.
Okay.
First thing you might want to do anytime you're given one of these pictures, doing these 2-column proofs, and again, that's what we're going to do a whole lot of. If you're watching right now, hopefully these will be a whole lot easier than the previous ones we did. I would look at this picture and I would probably separate the 2 triangles. It doesn't have to look spectacular or anything. Just separate them a little bit so you can see what 2 triangles we're trying to prove. All right? Does that make sense?
You just want to do this for every one of these that we get?
Probably.
Okay.
I mean, it's totally up to you. If you don't want to do it, I'm not going to try to force you. But I think it'll probably make it a little easier on you. The second thing, and you have to start doing this, a lot of you didn't do this the first time we were doing the 2-column proofs, you have to mark stuff in your picture. All right, so you have to label stuff in your picture. What's one thing they tell us?
KL is.
So mark that. KL is congruent to NM. Mark those 2 as congruent. Is that enough to say the 2 triangles are congruent? No. Right now we have a pair of what? Sides. So I usually write myself a little s over here at the side. That means I'm a third of the way there. What other given information did they tell us? So KM is congruent to NM, so mark that congruent. Is that enough to say the 2 triangles are congruent? We have a pair of sides and we have another pair of sides, right? Is that enough? No, we need 3 pairs or 3 parts, right? Side, 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 or side angle side. So we either need a pair of angles that would be in between those, or another pair of sides. Now is where we got to start coming up with stuff on our own. And as we go through this chapter, we'll make a list of stuff that you should be able to come up with on your own. Some of the things are like vertical angles. If we had vertical angles, you should be able to pick that out on your own without them telling you. All right? The one in this one is the one I've been saying for the last month and a half, 2 months that we're going to use a lot that we haven't used a whole lot yet.
Anything equals itself.
Anything equals itself. What do you know about segment LM in this triangle and segment LM in this triangle? It's the exact same thing. Anything equals itself. So that's another pair of sides. Do we now have enough to say the 2 triangles are congruent?
Yes.
And somewhere in our 2-column proof, we're going to put segment LM is congruent to segment LM, and that's because anything equals itself. And I'm not always going to write all this out. Just making myself some notes over there. Now, we got enough to say the two triangles are congruent, so now we come over here and we start to put it in the two-column proof. What's our first statement gonna be? KL, segment KL is congruent to segment NL. How do we know that?
Because it's a given.
That was given. Another thing that I do that you really don't have to do, if that was a pair of segments or a pair of sides in our two triangles, I put a little S out beside it, just to remind myself what information I've collected so far. Is that enough to say the two triangles are congruent?
No.
So now we go down. Does everybody see when I was talking about a pattern? Do you see what pattern you have?
Yes.
You know you got to prove a pair of sides, another pair of sides, another pair of sides. So you should know about what you're looking for. What's our second statement going to be? Segment KM is congruent to segment NM. How do we know that? That's another pair of sides, so I'm going to put another S out here. I look here, I got S, S. Is that enough? Two S's, is that enough? No, I need three S's, right? So now I go to my third statement. We're out of given information, so now we got to come up with something on our own. What was it? Segment LM is congruent to segment LM. Please make sure you're naming these the same way. Don't name one of them LM and the other one ML.
But,
Alright.
so that one's anything equals itself?
And then our reason there is anything equals itself.
So that's all we need to prove it?
So before we go on, so if I give you these two triangles, something that you should start seeing on your own every time, I give you these two triangles, what do you notice?
Cut them in half.
They share that side, right? What if I give you these two triangles? What do you notice? They share that side. Every time you see a picture that looks like this for the rest of the year, you should realize, hey, they share something, all right? What if I give you these two triangles? They share that side, don't they? All right? Now, a little tougher one. What if I give you these two triangles? Do they share this side?
Nope.
They share part of it, but not all of it, do they? So that doesn't work. How about this side? They share it?
No.
No. They do share something. Anybody see
They
it?
share the one point.
They share an angle. All right, so they share this angle. It's the exact same angle in both triangles. That's a little harder to pick out sometimes than sides are. Sides pretty easy to pick out when you're using anything equals itself. Angles a little tougher sometimes.
Aren't like the two sides at the bottom? Yeah. Aren't those? Are those the same size?
I don't know, maybe. But do they share it? Do they share that side on the bottom? No, because this one just cuts up through there and this one cuts up through there, right?
Would they share the angle
That
at the bottom?
so
The outside angle?
this angle?
No.
This angle?
The middle.
The middle angle right there.
This?
Yeah, would they share?
Now, that would work except is that angle in either of the two triangles?
No, but it's on the
So
outside.
when I pull them apart, is that angle even there anymore? So that's why sometimes separating them would be really, really helpful.
We can't write SSS though, can we? Like, that's not a reason.
So that was a pair of sides, so I'm gonna put a little S out here. Notice, does that give us enough to say the two triangles are congruent?
Yep.
Yes.
So our next step, soon as we have enough information out here to say the two triangles are congruent, next thing we're gonna say is the two triangles are congruent. Now, normally they'll already have named the two triangles for you. I left it blank here because I want you to match them up. I gave you the first triangle as triangle KLM. What's this K match up to in the other triangle? Say it one more time. Say just the first letter.
N.
N. All right, I just couldn't understand you for sure. What's the L in this triangle match up to?
L.
L. Right there, right? And what's the M in the other triangle match up to? So, and what you need to be able to do is, this picture, I know my triangles aren't going to look exactly like it or anything, but it looks something like this, right? You need to be able to picture the fact that, hey, on this one, you just flip the one triangle over here and it matches up to the other.
Yeah.
Now, is that always gonna work? No, sometimes you're gonna have to do this. Sometimes they might match up this way, where you have to spin the one triangle to get it to match up to the other. All right? Our reason. How did we know that those two triangles were congruent to each other? That's all you're right. Side, side, side.
We can actually write
Split
that.
segment.
That's one of the reasons. So when we start adding to our commonly used reasons over there, SSS is gonna be one of them probably. What's another one?
SAS.
Side angle side, and then we're gonna have a couple more as the,
Can we get rid of the ones we don't need anymore?
Symmetric property.
might wanna fill in that blank. You guys told me it was NLM, right? That we matched it up to.
Wow, that was easy. Still gonna suck at it.
That definitely made it like 5 times easier.
When you got a pattern, that's where all of you struggled. Okay, what am I looking for next? That's where a whole bunch of people struggled with these last time. Hey, where am I going to next? You have this pattern, you know you're using side, 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 then you know sort of what to look for. Now again, it could have been side, angle, side.
Can we do one that's side angle side?
Yeah, we might do that.
Man, I
Is
used
the
to
next
write-
one side angle side?
Man, I used to-
Next one. I'm not giving you no more
Arrow.
free passes.
You never give me a free pass.
Oh, I do too.
Uh-uh.
I'm not gonna let you use it.
He asks every single
I
day.
think I'm
When do I ever ask? First quarter, the only reason I use it because I use 2 passes.
On this one. Again, might want to split off the two triangles. One looks something like that, the other one something like that. My picture looks horrible, but I think we'll be all right with that one. What's this letter in this top triangle? A. How about this one? B. This one? C. D. A.
If you want to use a pencil, you can.
Actually, yeah, right. Use a pencil so you can erase it. Try to get by something on, or get something over on. What information do they tell us? What's the first piece of given information? So let's go up here. BC, that's right there. DA is right there, so that's a pair of sides. Is that enough to say that the two triangles are congruent?
No.
What's this next piece of information tell us? So that's parallel to DA. So on it, go back to the original picture. We want to put those arrows on there. So put those arrows on there to show that those two are parallel to each other. If those two are parallel to each other, then segment AC is called a what again? Starts with a T. Transversal. You gotta know that. You gotta be able to use it.
So does that mean that we can find the?
So if those two are parallel, this is a transversal. Anybody notice anything there?
They're alternate interior.
They're alternate interior. They form that Z, don't they? So what's that tell us about this angle and this angle?
They're congruent.
They're congruent. So let's mark those. Name this angle up top here for me.
C.
Can't name it with just C.
BCA.
BCA, good. BCA, that's this angle right here, so let's mark it. Name the angle in the bottom triangle for me.
CAD.
CAD. CAD, that's this angle. And that was, I'm just gonna write myself a little note over here. Those were alternate interior angles, right? Just so I don't forget it. So we had a pair of sides, that was just a pair of what?
Angles.
Angles. So instead of an S, guess what I'm gonna write?
A.
Is that enough to say the two triangles are congruent?
No.
But we have the other side.
We need another pair of sides.
Because
AC, in this triangle, what do we know about it?
it's
Anything equals itself.
Same in the other one, right? So it looks like this. Again, my picture won't look exactly like theirs, but looks something like this. They share that side right there. So anything equals itself. AC is congruent to AC. We're going to put that in our 2-column proof somewhere. Anything equals itself. Now you got to make sure that's another pair of sides, but what has to be true about the angle? Can it just be any angle? It's got to be the angle between the two sides. Is this the angle between the two sides in that triangle? Yes, no, maybe?
Yes.
Is this the angle in between these two sides?
Yes.
Yeah. So now we got another pair of sides. Is that enough to say the two triangles are congruent?
Yeah.
Yeah. So we should be able to go through here and do our 2-column proof. What's our first column called again?
Statements,
Write that down. What's our second column called?
reasons. Our given was, segment BC is congruent to segment DA.
Segment BC is congruent to segment DA. How do we know that?
It's given.
Give you a second to get caught up here before we go on. That was a pair of sides, so I'm gonna put a little S out there. Is that enough to say the two triangles are congruent? No, we got one pair of sides. We still need a pair of angles and another pair of sides, right?
Yeah.
Where did we go to next? Go to the next given. Segment BC is parallel to segment DA. How do we know that? Given. Now be careful here. Do I put an S out here beside that?
No.
We weren't saying that they were congruent. We were just saying that they were
Perpendicular.
other.
Parallel.
Parallel.
Jeez.
Soon as you see that you have parallel lines, what should the next thing you think of be? Alternate interior angles. Soon as you see that there's parallel lines, then probably the next thing we're going to put in our 2-column proof is that we have alternate interior angles. About 99% of the time, that's the way it's going to be on these. Somebody name the top angle, this angle up here for me.
Angle BCA.
So angle BCA is congruent to, what's the other angle? CAD. Everybody agree with that?
Yeah.
That was a pair of angles, so I'm going to put a little A out here. Now our reason. You got to be careful here, and you got to state it this way. If, and this is going to be one you might want to put an asterisk beside it when we're done with it, because every time you see parallel, you're probably going to use this reason somewhere. If lines parallel, then what do you know? What kind of angles were they?
Alternate.
Then alternate interior angles are what? Congruent. If lines are parallel, then alternate interior angles are congruent. Again, I would highly suggest that you put an asterisk, something beside that one, because we're going to use it a whole bunch throughout the rest of the year. That's one of those reasons it's going to get used a lot. Is that enough to say the two triangles are congruent?
No, you still need a side.
We got 3 steps, but we haven't got enough yet, have we? What was our next thing that we needed? Segment AC congruent to segment AC. How do we know that? Anything equals itself. And I'm going to put a little S out here. That was a pair of sides.
I need to get some.
Oh my god, we have SAS.
Is that enough?
Yeah.
We got enough out here now to say it, so the next thing that we should do is say our two triangles are congruent to each other. Triangle. Look, see this? They told us the triangles. I'm not letting you use that. Don't you dare write that down. Name the top triangle for me.
BAC.
BAC. Go with what Branson said there. Make sure you're using your symbols. Sorry, my other triangle symbol there is pretty small and ugly. Got to be really, really careful when you're matching these up. I have these two triangles, they look like this. Can I just flip it over and match them up?
No.
That doesn't work this time, does it?
It's,
This time it's got to sort of rotate around,
it's BC.
right? So B matches up to what?
D.
D, so put D first. A matches up to what in the other one? C. Notice neither one of those two are marked. And then this C up here is marked with the one arc, so it matches up to what in the other triangle? A.
B, C, A.
Oh.
So you gotta make sure you're matching them up correctly, because this one it sort of spins around to match them up
So,
instead of just flipping.
how do you prove that?
Same and
Reasons.
What's our reason?
Say it.
Side angle.
Why did I
Side.
listen to you? It's just spouting off random nonsense.
On a test, how many points would this be worth on a test?
5, 10.
10 points. Now watch. This is what I was talking about, and somebody said it. Oh, you should be able to get about half of it, at least. That's what we said on the other ones. You should be able to get probably about half of it anytime you're doing these, if you just fill in the given and the proof statements and all that other stuff. This time, should you get this point?
Yes.
Yeah.
Should you get this
Yeah.
point?
Yes.
Yes.
This point?
It's, yeah.
This point?
Yep.
So we're at 4 already. Maybe you have no idea what parallel means. Are you going to get this one? Probably not. All right? I hope that you do, because it's not that difficult.
Equals itself.
Should you get this one?
Yeah.
Yeah.
I hope so. If you don't get anything equals itself starting from today on, then we got major problems. Should you get this point?
Yes.
Yeah.
Should you get this?
Yes.
That's probably what we're trying to prove, so it's right there. So that's another one. This one.
No.
Maybe.
Maybe, maybe not. Right now, and this is, you might want to put this on your paper there. If you're proving two triangles, the only thing that can go is the reason there is side angle side or side side side. If you put anything else as a reason that two triangles are congruent, it's wrong. Period. The only thing that can go there is one of those two. Nothing else. So right now you have what kind of chance of getting that one correct? 50-50 chance of getting it correct just by guessing. So let's say you guess and you guess correct. How many points did you get? 8 out of 10. I would venture to say that there's several of you in here, if you got an 80 on every one of my geometry tests, you would be awful, awful happy. All right?
That one looks like it could be.
That's the assignments on your paper there. Get your books out. We got 18 minutes. We're going to do a couple of things up here together. Books out, page 309. Page 309. Books out, clean sheet of paper out. We're going to do 3 of these 2-column proofs together. That are on the homework there, so you won't have to do them yourself.
Mr. I made a pass. Thank you, Mr. What's the date today? Is it the 23rd? 23rd? What page are we on?
309? Going backwards, Mr. Ebersole.
Nice. Signature.
309, notice on this one. One of the problems you were supposed to do is problem number 3. You're not going to do problem number 3. What I want you to do is I want you to draw that picture that I have on the board there, and we're going to do the 2-column proof for that one. Draw the picture. You don't have to write down all the given and everything. Just draw the picture, and then we'll do the 2-column proof together for number 3. These can be out of order. I don't care if they're out of order on your homework. this is gonna replace number 3. Does everybody see that right there? Replace number 3. I didn't feel like changing the picture and stuff on my PowerPoint. What's the first thing I'm gonna mark on my picture up here?
You're gonna get the triangle separate.
Okay, well, if you want to separate them, let's do that. We got that triangle, we got that, that's horrible. We got that triangle. S, that's a P, that's a Q, right? That's a Q, that's a P, that's a T. So we separate those two triangles. What's the first thing?
Mark, SP and TP.
So mark this segment congruent to that segment. Is that enough to say the two triangles are congruent?
No.
No, but it's a pair of sides. Now what?
PQ bisects angle SPT.
So PQ bisects angle SPT. That's that angle. What's that tell us about these two angles?
They're congruent.
They're congruent. Are those two angles over here somewhere?
Yeah.
Yeah, it's these two right here, right? Name this angle for me.
SPQ.
SPQ. Name the other one for me.
TPQ.
TPQ. So that's a pair of angles. Is that enough to say the two triangles are congruent?
No.
The middle one's
This
the
is
same.
yeah, anything equals 6.
So segment PQ is congruent to segment PQ. Why? Anything that equals itself. So that's another pair of sides. Is that enough to say the two triangles are congruent?
Yeah.
We'll leave the pen laying up there. Watch. I'm going to do this one for you. What's our first reason going to be? Given. Hold on. I forgot. Got to do this. Why won't it let me do it? There we go. I'm going to, oh, that's got to go away. Sorry. So when you come up here, don't grab it, just grab it by one of the edges, and you're gonna slide it. Somebody wanna come up and fill in everything for everybody so that they can fill it in on their paper?
You guys can give me the
Go.
I'm done. I'm done.
Again, you should be filling this. This is one of the problems.
Wait, do I do all of it?
Yeah. Go ahead, Frank.
I'm not going, I'm not going.
What's the first thing Caitlin's gonna put in as her statement?
SP is congruent to TP.
Oh, God. Oh.
Did you mess up my?
Grab the corner.
Grab the edge.
No, don't grab the corner. Grab the edge.
Oh.
Try the other side.
Oh.
Yeah.
Oh.
Branson, please stop.
We could write an S out there next to it if we wanted. This is exactly the way that it'd be on the EOC test here in a month or two. Now, stop for a second, Caleb. Do we know that those angles are congruent? What do we need before we can say those angles are congruent?
PQ bisects angle SPT.
We need, they bisect, right? So that's actually gonna, where's that one gonna end up being? The third one.
That's why
And
it's
then
all
that one's in
stained.
the bottom.
It's up.
Right, front now down. Yeah. PQ bisects. That would be.
Yeah, that's number 2 there.
Oh.
How do we know that?
That's good.
That was given to us.
Corner.
Now, once we knew that that angle was being bisected, how'd you know that those two angles were congruent? It's over there on the board, I think. Yeah, maybe not. It might be another one that we need to put up there. What was happening to the angle? So if an angle's bisected, it's being split into what? Two congruent parts. Is that one of the reasons over there? She has it already. Sorry, Caitlin. Okay. So we have a pair of sides, a pair of angles. She needs another pair of sides, which is going to be segment PQ is congruent to segment PQ. How'd you know segment PQ was congruent to segment PQ? Listen to what I'm saying. How'd you know segment PQ was congruent to segment PQ?
It's equals itself.
Anything equals itself, and then the last part
Is side angle side.
is the two triangles and side angle side.
Okay, that makes more sense.
And everyone else, okay, there's probably as it is in the book.
Yeah, that's sort of it.
Like, are you putting any more there and saying it's?
Oh, no.
They're all in the book.
Yeah, they're the same as the ones.
Next.
Does everybody have that one?
Not all the way.
How many points would that be worth on a test?
10.
10.
How many points should you for sure get?
Oh, 7. Okay.
At least 7. Maybe you missed the very last reason, because it could be, other than side angle side, it could have been what? Side,
That's
side,
A.
side. So at least 7. If you get lucky and guess correctly, 8. Hopefully you get them all, because this isn't all that real difficult. Hopefully you know if an angle's bisected, it's being split into two congruent angles, so you can name the angles.
Do all the ones that are like built like that and usually have 5?
Not always, but. Somebody go up there and switch the slide for us, so everybody gets, you just have to click over here on the left-hand side on the next slide.
Jackson, you got it?
Do I?
We'll help you.
Not doing anything but switching the slide for right now.
Yeah,
Is everyone done?
Everybody got that one yet?
I just got done.
Yes, no, maybe?
Yes.
This one is number 5. Number 5. This is number 5 on the homework, so I probably skipped number 4. Number 5. Again, I don't care if they're out of order on your paper or not. What's the first piece of given information tell us?
QR is congruent to SR.
Now, do you have to separate the two triangles off? When the picture looks like this, I probably wouldn't even bother to separate them off because it's pretty easy to see which two triangles you're dealing with, right?
Yeah.
So QR is congruent to what?
SR.
SR. Ooh,
It's segment.
I think I messed up here. I should say segment ST, I think. Look at the, in your
QR
book.
equals SR.
Is that what it says in the book?
Yes.
I probably got these in the wrong spot then.
And then ST
What's this point in your book?
R equals Q.
That's R?
Yeah.
That's T?
No, that's right.
That's Q?
Everything's right.
Yeah, everything's right.
Everything's right?
They're just doing it a different way.
So QR is congruent to SR, that's this one? Is that right?
Yeah.
And then what's the next piece of given information tell us?
ST is
My
congruent.
picture's just off, isn't it?
Segment
No,
ST
your
is
picture's right.
congruent to
No,
segment
it's just
QT.
stretched out.
It's stretched out. In the book, I think it looks like a square.
It is a
Yeah,
square.
that's what it is.
So those two are congruent, is that enough?
No.
No.
What else we need?
The other, TR. The TR is
TR is congruent to itself, right? Now, is that enough?
No.
Yeah, side, side,
Side.
side. So we should be able to go through, somebody go up here and drag and drop them.
I just want these. I can do this. Okay, I'm gonna try and figure this out.
You were the only one that left.
I was getting ready to tell Caitlin to be ready, because Branson was the one oohing and on every time you were messing something up, right? But he's doing it correctly, so I was gonna have you make fun of him, just like he was doing you, but give him a chance, he'll mess up here in a minute.
That's a pretty accurate impression.
There it is! Ah!
Wow.
Go up and hit the back button, the back arrow up top.
That's very, very tough. On the left is English. Falling to this chair.
Sit
Very
there,
top.
yeah.
Big the stroke.
And I can see it.
Well, it's not even a nervous laugh.
Oh.
How do you know the segment RT was congruent to segment RT?
It's on that section.
No.
Yeah, common sense is what I use.
I don't believe that.
You just
Air
turning
burning.
it's no hard. You've been trashing your whole class. This whole year, you've just
Cameron,
been
you cannot
steady
go out
on
and
Branson.
Dude, shut up,
Right,
Sarah.
you
You
have
can't
a tiny
talk
head.
What happened?
Yeah, grab.
I did grab it, it moved.
Apparently not good enough.
You keep trying to grab it there. Now grab it. Now don't pull up. You're grabbing it in the middle. You gotta grab it over. Find someplace else. There you go. No, quit going back to the same daggone spot.
What is it? I have a question.
Grab it on the side.
It's too small.
What you do?
Just write it there.
What?
Really?
See that?
This segment right here.
Yeah. No, I was too busy listening to Suddenly.
Graham, right, we got 5 minutes. There's one more up here that I wanted to get done.
Somebody switch them.
Is everyone done?
No.
Go, done enough,
Yeah,
go.
Next one. You got this. Who don't got it? That's their problem.
If they ain't got it, it's their problem. Go, 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 go. Then we're keeping up.
Want me to do it, Caleb?
Wait. Wait. Do it.
You just
You
kidding.
erase all the stuff.
Oh my gosh, I didn't have right any of it done.
You got this, Caitlin. You got it.
So this is 12?
First thing, let's just think this through because we just got done doing one just like this. What do you see in the second given?
It's a
Parallel. As soon as we see parallel, what should we think of?
Transversal.
Alternate, transversal, and
Alternate
alternate interior
interior.
angles, right?
Yeah.
Somebody name the two alternate interior angles up there for me. Remember, they form a Z.
C-A-D.
B-A-D
C.
and C-D-A. All right?
Yeah.
So we should be able to go through and do this. Let's go ahead.
What number is this? 12?
Well, this is number 12 on the assignment.
On you, boss.
You don't even have to mark it if you don't want, Caitlin. You can just shove it in there.
You do the, yeah. The given is A, segment A. We might be B, congruent.
What's this?
Segment
What
C.
number is this?
72.
Segment A, B.
We've said it like 7 times. Again, remember your 2-column proofs. As you're going down through and doing it, if we say that it's got to go in some common sense order. If we say parallel, next thing we should look for are those alternate interior angles.
Is that, yeah, that's right, right?
So if lines are parallel, then what do we know? Alternate interior angles are congruent.
Yeah. It was like,
Oh my God, forget it.
Now, how do we know it's side angle side and not side side side?
Because
Add a pair of angles, right?
That still looks bad.
you know that old video game in the arcades, like Duck Hunt? I bet Mr. Ebersole played Duck Hunt. Yeah, yeah, I know. I bet he was good at it too.
It's a good showing that you were listening to him because they needed somebody to listen to that.
Well, can you just look at this and say, like right here, can you just look at the picture and put your givens if they give us the picture? Like instead of writing the parallel, can I just put NPL is congruent to NPL?
Oh my gosh, I just had to write so fast.
Do I have to write
Sorry.
parallel and then put 1, 2,
No, I had everything bad.
Yeah.
I mean, don't you do that. Don't you do that.
Yeah,
Yeah.
you have to say, okay. This angle are 90 degrees. Then you gotta say those two angles.
Working
All
out.
right angles are.
I had to freaking run.
He had to freaking run. That's man. That's idiot. Stupid. Said I had to freaking run. That's idiot. Stupid. Yeah.
I had to run.
Oh, man. Mr. Ebersole, did you play Wii Sports? I bet.
Branson, are you gonna ask me a math question?
Did you like Duck Hunt? Did you ever play Duck Hunt, the arcade game?
Kelvin, they're talking again.
I'm
really not
Have a
worried
good
about
rest of your
you.
day.
I bet you were a king at Duck Hunt. I just bought a thing of 20 gauge ammo for like $10. It's the cheapest I've found it all year. I've had to pay like $40.
I'm literally the best
I'm
freshman
really, really happy.
in this whole class.
The
Did you watch the game yesterday? Both of
Uh-huh.
them? Did you watch both of them?
Yeah, I watched most of the other one. Not all of it, but most of it.
I think it'll be Bengals, obviously, and probably the 49ers. I don't know. I feel like Brock Purdy's gonna struggle.
May.
But I got Bengals gonna win the Super Bowl.
Have a good rest of your day.
Yeah, you too.
You're ready to ask questions off the review packet. I'll answer anything that you want to see work off the review packet before the test. And make sure you have calculators.
We were doing our research. I didn't do it.
Don't judge me, I'm hungry and Brendan ate all of the food.
Jackie, I cried this morning.
Fruit snacks and two granola bars.
Me too.
And
Okay?
you said you were absent. I had to take like 5 minutes to come back here and cry. And my first walk in.
I was not absent. My mom literally called and said that I was gonna be here.
They had to do this after.
Okay, well they're stupid, so. And you know what? I should have been. I was already late. I should have just not come.
Sorry.
No, I shouldn't have, because then I would have.
I think we should have just canceled. I about like formally emailed him. Like I wrote it up and everything. I was like,
You ready to ask questions on the review packet
circumstances
for the test?
getting canceled. We should push the back. The chapter 5 test.
Much better.
You should just email him anyways.
Much better. How many times you shot? Oh. Throw the ball over there. Heck with all of it. Let's watch how some of them
I
shoot.
didn't write down the similarities or differences of it.
I didn't think Valley had that many shooters.
They'll never ever hit that many threes again. And number 5, I ain't seen him make 2 threes all year long.
Yeah, I don't think he missed three.
I was setting number by my aunt and uncle, and he made like 4 in a row and plus made a layup or something. And I said,
That's
you
what I
probably make a
thought.
shot the rest of the game.
Well,
Well,
we
he made
can-
the next 3, then after that he'd make a shot the rest of the game.
Well, there's a specific person on our team that doesn't
Saturday,
count.
about 4
When
hours.
somebody's not, and they let them shoot.
And coach.
And the kid that was guarding Kelvin just about the whole time. No,
And then
the
on
other
Sunday
one.
to a note on the board.
Yeah, he made 2 threes.
Oh, thank you so much.
I ain't seen him make.
Gabe's made 2
I was
threes.
just so I hope you know I did all of that. She didn't even
Gabe,
get her
you're
one
1
mark
three
today.
away, man.
She goes, I know.
The bank,
Oh.
I don't even really count that.
I need to call.
I looked at the bench and
They're
I was
gonna
like,
call me back.
yeah, that's what I said. I was like, 3 points? Yeah.
Zero is probably their best basketball player. He didn't care.
He didn't play good, really.
He played
Five.
good. You know, because he didn't care. He probably didn't want to be there.
Yeah.
Huh?
People that are good just give 0 cares.
And you see what he did. When he starts doing that, he drive, throw it up. Sometimes him and that five is athletically he's pretty good, and he can make some shots, short shots, not usually threes. And usually him and that five, like the last game I went to, that 5 had scored like 15 points, and that 0 had like 10. He was shooting every single time down the floor because he was not going to let him outscore him for the game. That's what he cared about.
That's what Kellen was doing towards the end of the game. Me and Nick were hot, and then Kellen just pulled up 3.
So when you got guys like that on your team, and so 0, but you know he had like 2 points or something going into the second half, and that 5 already had like 15.
And 0 kept shooting.
Yeah, he kept shooting, and then when he figured out I'm not gonna catch him because I'm not making nothing, then you see he didn't play the rest of the game because he acted a jerk and didn't care.
Where's the senior season dunk? That's coming.
And did you see 5?
Oh yeah, the halftime.
And my son said, "Oh no, he can dunk, Dad," because my son and him. Yeah, he didn't get his hand to the rim. He wouldn't have touched the rim with his hand if he didn't have the basketball that time. He said, "No, Dad, he can dunk," because my son and him compete all the time trying to dunk.
You're gonna attempt to dunk in the game, you gotta make it.
Right.
Especially before halftime.
Yeah,
So
like late in, that was a definite, you lay that ball in, if you can't dunk.
You only dunk if you know you can't dunk for sure.
If you're lane server.
Because then you end up like that.
This
Dude.
far over the rim, like.
Dunk it in
two
here.
balls length
Yeah.
over the rim, so there's like. We do number
If you're Weddington, dunking you.
If you're up 40, yeah, dunk.
Yeah.
Right? Try to dunk.
problem number 9. I hope I got the right paper.
Not the heart rate.
I see it.
The time spent in days waiting for a heart transplant for people ages 35 to 49 in recent years can be approximated by the normal distribution, where the mean is 289, is that what it says?
Yeah.
And the standard deviation is, what's that say? 17.8. Part A. What waiting time represents the 20th percentile? So we got P20. All right? If P20, if we're looking at our graph, and again, some of these I asked you to draw a graph, some of them I don't. I would highly suggest that you draw a graph on a lot of them just so you can see this. 20th percentile, what area is that telling us that we want to the left? Point 20, right? So, is that going to be above or below this 289? Is it going to be to the left or to the right? Left. And we know that that should be like 0.50, right? So it's going to be somewhere, maybe way down in here. So we're looking for that area. Just gives me the idea that nothing, this graph really has nothing to do with the problem. Just gives me the right idea where am I going to be at. So I could almost guess and say, okay, I'm about 270 or something like that. If I come up with 300, I know I screwed up somewhere. On this, how do we do it on our calculators? Since we know the area. We just use inverse norm, right? Correct? What goes in when we're doing inverse norm? What, three things, I think there's three things we put in. Area,
Standard deviation.
mean, standard deviations. So this time, what's our area? 120, what's our mean? 289, what's our standard deviation?
17.8.
Somebody help me out.
274. Yeah, just 274.
What do they come out to be? Tell me the number calculator actually do.
274.019.
So we want to round that off because it's days, so we're going to say about how many days? About 274 days. If you rounded it up to 275 days, I probably wouldn't mark it wrong. Part B, what's the waiting time that represents the second quartile? Second quartile, anybody remember anything about the second quartile? 50%. So if I'm looking on the graph, 50% of the data should be to the left, so it's gonna be right at what? 289, we're looking at that. We could plug this into our calculator, we really don't need to. What's the number of days that we're gonna be waiting? 289 days, because that's the second quartile. Now, if we plugged into our calculator, it'd come up this way, it's 0.50, 289, somebody plug this in and see what they come up with. 17.8, inverse norm again. What's it say? 289. So if we know the area and we're trying to find the raw score or the z-score, then we're using the inverse norm. On all the other stuff, we're using the normal CDF thing. If we know the z-score or the raw score and we're trying to find the area or the probability. Other questions?
Number
3D?
3D.
We don't want to do the others, just D.
Yeah.
Z equals, somebody help me out,
3.1.
3.1. So on this one, we know where the z-score is. What's it say? It says to the right, doesn't it? So if we're on our z-scores here, that's 0, 1, 2, 3, and we got the other ones back here behind that. I'm not gonna label them. We're at 3.1, so we're like right here, and we want stuff to the right. If we're looking for that area or that probability, should it be a big probability or a small probability? It should be really, really small. Remember, if we're more than 3 standard deviations away from it, very unlikely. Remember, this is where Ebersole scores at compared to everybody else, right? Don't be snickering, Ryan. So we do that. Now we're going to use, I can't remember how it is on the calculator. So say normal or just norm CDF? Is it normal? So it's at, oops, what do we put in our calculator for the normal? I think there's 4 things that we have to usually put in, but not always. Lower, upper,
Mean and standard deviation.
mean, standard deviation. Now, if we're doing z-scores, do we have to put in the mean and the standard deviation? No, the calculator just takes it for granted that that's what we're doing. This time, what's our lower limit? 3.1. What's our upper limit? Normal CDF that, what's it come out to be?
0.00097.
How many zeros?
3.
Is that what we said? We say it should be a real small amount? Yeah, and this is actually like 0.09 of a percent. So, not very likely. Other questions? 12. Somebody want me to do one off of that? The rest of that same problem? I thought somebody said that. No? 12. Brian, if you don't take that thing out of your ear, I'm gonna have it, and by the time you get back here to get it, it'll be sold. Put it right on eBay. Nickel.
For a nickel?
Yep.
That ain't gonna work.
I don't care if I made any
Costs
money.
more to
I
sell
just
on
wanna
eBay
have
for
it
that
as
much.
is.
I mean, technically you would still make a profit because he didn't buy it, so.
I don't think you make any profit. I think it costs more to ship it.
I just think that this-
Are we doing all of number 12?
Preferably.
Yes, all right. Letter A, first, you gotta hurry then, so we can get the test started. Says a survey of US adults ages 18 to 29 found that 93% use the internet. You randomly select 100 adults ages 18 to 29 and ask them if they use the internet. First of all, our mean is what? Mean for the entire population is what? 93%, right? Standard deviation, they didn't tell us, but the mean of our sample means, or the mean of our binomial, let's go that route. Mean of our binomial is gonna be n times p, right? What is n this time? How many are we putting in the group? Times 0.93. This is p, not n. That's why you guys were looking at me stupid or not saying anything, right? What's 100 times 0.93?
93.
So our mean is 93. Now our standard deviation, we find it by doing what? Which we already did n times p, that was 93, right? What's q this time? 0.07, make sure you bump it over 2 places. Somebody do all that, tell us what that is about. 2.55 we'll say, is that close? So we got our mean, we got our standard deviation. Gotta make sure you find those first. Part A says, find the probability that exactly 90 people say they use the internet. Now we should check to make sure that we can use the approximation, all right? We know P is 0.93, Q was 0.07, N was 100. Well, we know 0.93 times 100, that's more than 5, right?
Yeah.
Is 0.07 times 100 more than 5? Yeah, so we're okay to use that. So we can just use our calculator and use the normal CDF on all of them. Just like we've been doing on the other stuff. First one, P, probability that X equals exactly 90. We're gonna plug into the calculator. I probably shouldn't have an equal sign there, but I don't care. Normal, CDF, what are we putting into our calculator? What's our low limit? Be careful. What do we want to change this to? 89.5. And what's the high side then?
90.5.
90.5. Since we're doing the approximation, we have to do that. Why can't I remember anything today? We have to do the correction. What was it? It's something, continuity correction, right? So what's my low limit? 89.5. What's my high limit? 90.5. What's my mean? 93. What's my standard deviation? 2.55. Might do that for us. When we get this area, should it be a big area? Because all we're finding, our mean is 93. We're at 90, and we want just that little part right there around 90.
0.784.
0.784. Anybody else get that? I actually think it should be.
Oh, yeah, right. So
Next one says we want x greater than or equal to 90. What do we need to change that to before we start putting it into our calculator? If we're going bigger than, we want greater than or equal to, I think, yeah, greater than or equal to 90. Where are we starting at? 89.5, go down a half. Long alligator mouth. And what are we going to go up to? 10,000 maybe? So in your calculator, what are you going to punch in? What's your low limit? 89.5. Your high limit? 10,000. Mean standard deviation are the same. So what's that come out to be?
0.9151.
Anybody else get that?
Yep.
Now, again, might have helped if you drew it. We're at 93 here. 90 was down here. We want to go from there up. Should that be a pretty high percentage? Yeah. C, fewer than 90 people say. A couple different ways we could do this. We could do the same thing that we've been doing. So we want fewer than 90 people. So that, what's that going to change to? Be careful. Do we want to include 90 this time?
Oh, no.
So we want 89.5 and down. What's your low limit going to be? Close. Negative 10,000. If you put in 10,000, I did this several times because my negative button didn't work very well on my calculator. And it says what?
0.08.
Now, if I put in 10,000,
Oh,
it'd say error.
If you put in 10,000?
If you put in 10,000 and your upper limit's 89.5, it's going to say error.
Yeah.
And I kept wondering, why is it saying error? Then I'd look back and my negative button wasn't working. So what did the actual answer come out to be?
0.0849.
Now, the other way you could have done this one, anybody notice anything about these two? They should, this one was this, the other one was same thing here at this spot, only going what? The other direction. So those two together should add up to what? One whole. Look at this number, look at that number. If you add them together, does it come up to 1? And if it doesn't come up to 1, it probably comes up really close, like 0.99999. Letter D, what did letter D say?
It's asking which removing say there's zero.
Any of these unusual? Let's see, where was our answers? This was one answer. That was an answer, that was an answer. Any of these considered unusual? No. Why not? How do you know if something's unusual or not?
It's less than 5%.
If it's less than 5%. Is that one less than 5%? No, it's 7.85%. This one's 91%. That one would be about 8%. So no, all, more than 5%. Make sure your names are on those. You're going to lay them on the desk right there behind Sean. See how nice I am to you, Sean?
Thank you. Always cheap.
Get up and move these around. Hold on a second, Ben, then I'll show you.
That would have been an air ball if I was in the corner. If I was in the corner shooting that, that's an air ball.
Sorry, but
I air ball twice. It was pretty bad.
Yeah, you got this guy named, Monty or something, Bonnie.
low limit.
But their highest average is 11, their highest rebounds is I think 8.
Can you use your notes on this? Calculators, nothing else? Take your time, make sure you read the problems carefully, show your work.
You should do it after you take a test. Did you know you can make prison wine? Make prison wine. That's.
Get finished, bring it up to me. Again, some of it you can show your work on, some of it you can't, but if you write down something, that, you know, even to just say, hey, this is what I used on my calculator or something, and you mess it up, maybe I'll give you partial credit. Can you get finished, bring it up to me, and good luck.
Probably.
No.
Perhaps.
No.
No.
Perhaps.
Have a good rest of your day. Lexi, you gonna help him walk? You gonna help him walk? Apparently you couldn't.
I'm saying if it's